right, so this is going to be the quick review of section 5.3. It's solving systems by elimination method. Now we've done the graphing method, we've done the substitution, and now you're going to learn a third method. It is the elimination method. Sometimes people call it the addition method. All right. Basically, it involves adding the two equations in such a way that one of the variables is eliminated entirely. So you're going to be adding the two equations so that one of them variables is eliminated. So let's just take, here we got a system of equations. We've got two equations here. And so we want to add them together so that one of the variables is eliminated. Well, if I look here, minus 3 plus a negative 2y, this does not cancel out the y's. In fact, we get a negative 5y, right? But if we look here, 2x plus a minus 2x would give me zeros, and so this cancels out. So watch what happens when I add these two equations. So I'm going to add this here. Okay, I'm adding them together. 2x minus 2x is 0. Negative 3y minus 2y is a negative 5y. And 12 plus 3 is 15. So I've taken the two equations, I've added them together, and one of the variables canceled out. So I'm left with a negative 5y equals 15. I'm going to solve for y, divide both sides by 15. This becomes 1. I get y equals 15 divided by a negative 5 is a negative 3. Excuse me. So now I have one part of the solution. Now I'm going to take the one of the equations, and it doesn't matter, which one of the equations. So I'm just going to take the first equation. 2x minus 3y equals 12. So I'm going to take this first equation. I'm going to substitute this in for the solution so that I can now solve for x. Well, 2x, negative 3 times a negative 3 gives me a positive 9. Subtract 9 from both sides. That gives me 0, so I'm left with 2x equals, then 12 minus 9 gives me a positive 3, right? And now I'm going to divide both sides by 2. This gives me right here, this gives me x equals 3 halves. 3 halves is the same thing as like 1 and 1/2 or 1.5. So what is my solution then? Well, my solution is, if you look here, my solution is x, when x is 1.5, then y is a negative 3. This is my solution right here. This point, 1.5, negative 3. And I've done that, again, this is called the elimination. So by just adding the two equations and solving. It seems quite simple. And you're going to learn different methods, and so you're going to pick out, and eventually as you get better at it, you'll know which method is the better one to use in certain situations. If you look at page 164, you can see at the very top, there's that chart. It kind of goes through the steps. One first step, though, that it talks about is that you always write the equation in standard form. ax plus by equals c. Remember the standard form. Well, these were already in standard form. ax plus by equals c. ax plus by equals c. They were already in standard form. But they might give you an equation where it's not in standard form, and if so, you have to rewrite it. Okay? Now, if a system doesn't have a coefficient with one variable that adds up to 0, like for example, this happened to have a coefficient that added up to 0, you might get two equations where this is not the case. It doesn't add up to 0. If that's the case, then you're going to use your multiplication property and find kind of the least common multiple to multiply by the equation before you add. So let's do one of those examples. For example here, notice that 5x plus 3x is 8x, 2y minus 9y is 7y. None of these canceled out when we just simply added them, right? So what we want to do then, by the way, and I'm doing I'm doing problem number 23 on page 166. I'm not even doing one of the example problems from the book. I'm doing number 23. And so, excuse me. Hold on, I'm having throat problems. All right, so in order to get these to be common coefficients, I could multiply this whole equation by 5, and that would give me 15x here. And if I took and multiplied this whole equation by 3, that would give me 15x. And then I would have that scenario, and the x's would cancel out. I could also do the same thing for y. Okay, so I'm going to go ahead and do the y's. It doesn't matter which one you do, but I want you to see what happens. So I'm going to take this one right here. The 5x plus 2y equals 20. And this one right here, I'm just going to write it off to the side so that you see what happens. Because I want these to cancel out, I want my least common multiple is 18. So I'm going to multiply this whole equation by whatever this coefficient is, which happens to be 9. And they're choosing this one because these are already positive and negative. And that's why they're choosing to use this. If this had been a positive and this one had been a negative, then it might have been better for you to have chosen these. But you'll begin to get better at what ones to choose. So I'm going to take this right here and I'm going to multiply 9 times this equation. Okay? And then I'm going to take this equation here, okay, because here I'm multiplying this one by 9, right? Because here's where the 9 came from. I want to multiply this one by 2. And I can do that as long as I multiply 9 times both sides of the equal sign. Excuse me. By both sides of the equal sign, I'm not changing the value any as far as the scale goes. The scale's still balanced. Remember your multiplication property. I can do this. So 9 times 5 here gives me 45x. 9 times 2 gives me 18x, or 16y. And 9 times 20 gives me 180. And I would take 2 times 3 here gives me 6x. 2 times this negative 9 gives me a negative 18y, and 2 times 12 gives me 24. Now the whole point of why I chose these numbers is because now look what happened. When I go to take the two equations, these two equations, and do what we did earlier and add them, all right? Sometimes remember they call this the what? Addition method or elimination method, because we're trying to eliminate a variable. Well, it worked because 18y and minus 18y becomes 0, right? This becomes 0. And if I add 180 and 124 here, I end up with 204. And 45x plus 6x gives me 51x. Okay. So now I have 51x equals 204. I'm going to divide both sides by 51. This becomes 1. X equals 4 when you divide that out. All right. So I have one part of the solution, right? One part of the solution is 4. So I'm going to take this 4 and I'm going to plug it in. And it doesn't matter into one of the original equations. It doesn't matter which one. I'm going to go ahead and take the first equation, 5x plus 2y equals 20. I'm going to substitute this in for x. So 5 times 4 plus 2y equals 20. 20 plus 2y equals 20. Subtract 20 from both sides, right? This gives me 0 and 0, so I'm left with 2y equals 0. 2y equals 0, sorry about that. Because I've subtracted 20 here. And now I'm going to divide both sides by 2. This gives me y equals, remember 0 divided by any number is 0. All right, so here's our x and our y, which means our solution is 4, 0 is our solution, is 4, 0. Now, do your check step. Check step, remember you take your solution and you're going to plug it into your two original equations and make sure you get two true statements. I'm not going to take the time to do this check step at this time. All right? So those are basically the two type of examples that you would get. Like I said, I didn't do the examples in the book, so if you want some more examples on this, feel free to look at section 5.3, some of the more book examples that they've given.